Ladies and gentlemen, we will present our study topic, which is effectiveness of Moringa seeds in purification and antibacterial of Calumpang river water. And the presenter will be myself, Maria Tereslin and Aureliano.
I'm Miko Angela Baganas.
I am Darlene Bidigo.
I'm Ken Edi Castro.
For the introduction, one of the most essential things in this world is water. It is a vital way of life on Earth, and which is a key factor of sustainability, economical, social, and environmental. Hence, a lot of people is experiencing insufficiency in regular supply of clean water. The largest river in eastern Batangas is the Calumpang River in Batangas City. It forms the southeastern boundary of Poblacion, Batangas Province, as it flows southward to Batangas Bay. Both people and animals' waste is expected to be poured into the river system with proper waste management. The ecosystem services in Calumpang River has been altered by the intensive sowing industry in the river's watershed. In addition, the water will begin to degrade with a drastic intervention, and the deterioration of Calumpang River will be intensified if both human and swine population continue to develop. As the river situation continues to worsen, solution for this problem should be developed too. Moringa oleifera, commonly known as malunggay, is a plant that grows in tropical climates including the Philippines. It is commonly used as vegetable ingredient, herbal medicine, and other practical uses. Each part of this plant plays an important role in every situation. It contains calcium, magnesium, protein, vitamins, and many more. That's why it's called a superfood. In addition, moringa seeds that are harvested from the pods of malunggay plant plays an important role too. It has the possible characteristics to solve the big problem of Calumpang River water. Several studies have shown that moringa seeds turn the polluted water and untreated water to purify and comes with low turbidity of water. So, this research aims to develop an initial method of purifying water of Calumpang River by considering its huge potential for ecosystem services using a cheaper and eco-friendly alternative solution.
For the discussion, this study is conducted in order to test how moringa seeds can be a purifier and antibacterial in Calumpang River water. So the researchers gathered data from previous studies to know how moringa seeds can purify and remove the bacteria from the river water. Calumpang River in Batangas City has a huge benefit for ecosystem services, but now its potential was obstructed when its water quality reduced. There were characteristics of water in regards to physical and chemical. So, Calumpang River is considered from ecotourism development by Batangas City government. It has a catchment area of approximately 472 square kilometers. The river characteristics within the total basin system are related to a number of features, including its physical characteristics, which pertain to its color, sorbidity, odor, temperature, solids, and also its chemical characteristics concerning dissolved oxygen and pH. So, previously, there were results of water quality monitoring of the Calumpang River from quarter 1 to quarter 4 in the year 2019. It included the ENR criteria for Class C waters, the recorded result in every quarter, and the total average. So, the parameters are nitrate, which has a total year average of 0.733, and it didn't reach the DENR criteria. Next is phosphate, that has 2.462 concentration over the years, wherein it exceeded the DENR criteria, same as the chlorides that has a total average of 2,244. Next is the color that has a total of 13 TCU, and dissolved oxygen that has 5.1 that didn't reach the DENR criteria. Moreover, The BOD that reached the DNR criteria has a total concentration of 9. The pH that has a total year average of 7.5, the TSS that has 34, and the temperature that has a total of 29. And lastly, the fecal coliform that has a total average count of 48,118 totally exceeded the DNR criteria. Moving on, Calumpang River has affected by many factors that make the river polluted up to now. Calumpang River is identified to be a principal river along with many tributaries such as Malaking Ilog, Sabang, and Ibaan rivers draining from the municipalities of Ibaan, San Jose, Taysan, as well as Padre Garcia and the cities of Lipa and Batangas. Over the years, the river turned out to be toxic and polluted due to the growth of pollution from a variety of sources near the river. So, Calumpang River is classified as Class D river based from DNR classification, implying that it now serves as a receiving body of discharges or a catchment. By being stated, the river could only be utilized for agricultural and manufacturing purposes once undergone treatment. To sum the waste Calumpang River received, rough estimation, it is approximately 16,991 kg of waste. So next is summary of parameters that causes pollution of Calumpang River. This table displays the summary parameters that cause pollution of Calumpang River from different areas around Batangas, which are Batangas City, Ibaan, Lipa City, Cuenca, Taysan, San Jose, Rosario, and Padre Garcia. The driving force as to why Calumpang River is continuously classified as polluted are the driver forces such as industrialization, urban development, and agricultural activities. So it is increasingly being threatened as the human population grows and demands more water of high quality for domestic purposes and economic activities. So, one of the examined major sources of pollutants present in Calumpang River is the high density of swine population within the Calumpang watershed. So, most of these were said to destitute proper waste disposal and sowing both human and animal waste to be dumped into the river system. According to Dr. Rico Aknog, Sherka Operations Consultant for Emerging Innovation for Growth, the source of phosphate in the river must be the animal feeds discharged into the water. Some sources of water pollution identified present in Calumpang River are mainly from scattered or diffuse materials having no specific location where they discharge into a particular body of water. This includes agricultural runoff and industrial effluents wherein often discharged into the environment or stored in vast or lagoons from which waste may spill or leak into nearby streams. So, in addition, in large complex systems, fecal pollution can be introduced from multiple sources including sewage overflows, agricultural runoff, and urban stormwater. The presence of fecal coliform bacteria in aquatic environments indicates that the water has been contaminated with the fecal material of man or other animals. So, fecal coliform is a group of bacteria that are passed through the fecal excrements of human, livestock, and wildlife. These are examined to be present in Calumpang River as well. This organism may be separated from the total coliform group by their ability to grow at elevated temperatures and are associated only with the fecal material of warm-blooded animals. The presence of fecal coliform bacteria in aquatic environments indicates that the water has been contaminated with the fecal material of man or other animals. Moringa oleifera seeds. One of approximately 13 species in the genus, Moringa oleifera is a family that is monogeneric. Moringa oleifera has been naturalized in various tropical and subtropical regions of the world. A wide range of common tree names including benzolive tree, drumstick tree, horseradish tree, keller tree, and best friend of mother, never die tree, malonge, munga, malunggay, and many others are known. So, effectiveness of moringa seeds in purification of water. Moringa seeds consist of protein that is identified to be the flocculating agent, an important characteristic used in water treatment which is identified as effective in improving the sedimentation or filterability of small particles present in a sample. So, as a natural coagulant, M. oleifera provides many benefits and is efficient in wastewater treatment processes. In terms of the extraction and purification of active components within the seed kernel, many technical and economic challenges remain to be resolved. The use of crushed Moringa oleifera seed as a natural coagulant offers a feasible alternative. Prior to harvesting, the seed pods are permitted to dry naturally on the tree. Powder process from moringa seeds has been shown to be one of the most effective as a primary coagulant for water treatment of all plant materials tested over the years and can be comparable to that of aluminum. In addition, the use of moringa, since it is biological and has been identified as edible, has an added benefit over chemical water treatment. Moringa seed in water treatment. So, the coagulation mechanism of the Moringa oleifera coagulant protein has been explained in different ways. It has been described as adsorption and charge neutralization and interparticle bridging. Flocculation by interparticle bridging is mainly characteristic of high molecular weight polyelectrolytes. The unique property, stability of its dry, crushed seed and seed press cake, which contain polypeptides, is to serve as natural coagulants for water treatment. In addition, as dosage of Moringa oleifera seeds, the removal efficiency was seen to increase as well. Hardness removal was found to be independent of pH of the raw water. Moringa seed as antibacterial. In the study entitled Antibacterial Activity of the Leaves, Bark, Seed, and Flesh of Moringa oleifera, the researchers stated that significant antibacterial activity was demonstrated by benzen, methanol, and aqueous extracts of Moringa oleifera. Leaves, bark, seed, and flesh with the zone of inhibition range from 7 to 23 mm. With that being said, it supports the researcher's study. E. coli is one of the active bacteria present in Calumpang river water. This study has shown that water-soluble extracts of moringa seeds had antibacterial activity against E. coli. Moringa seed powder is an excellent coagulant for clearing untreated turbid water from a polluted river. The added benefit of moringa seed is that they have antimicrobial properties. Considering that palunggay plant is widely grown in the Philippines for use as a vegetable, the moringa seeds will be easily available for the treatment of water. The high cost of the new water treatment schemes is likely to be decreased by this, and it is used in water purification, and it should be encouraged.
So now let's move on with part 3, materials and methods, and I would tackle first the testing of parameters of Calumpang river water. Nitrate, this is a compound that consists of nitrogen and oxygen. So it is measured using one of the optional ion-specific electrode or ISE that attaches to the upper probes. So the nitrate probe has a sensor to measure the nitrate activity in water sample. The change in potential is measured in millivolts and as shown as milligram per liter. So the nitrate ISE has a range of 0 to 1000 milligram per liter and is accurate to positive or negative 10%. In nature, phosphorus usually exists as a part of phosphate molecule. Insoluble phosphorus is calculated by subtracting the dissolved phosphorus results from the total phosphorus results. So this is accomplished by first digesting, heating, and acidifying the sample to convert all the other forms to orthophosphate. In determining the amount of chloride present in water samples is done by Morse method. So basically, this Morse method stated here is the testing and determining of chloride ion concentration present in water samples by titration. So titration, this is a laboratory method used to measure the unknown concentration of known substances. Color can be measured by our eye. However, this is not suitable for certain types of contamination such as from those industrial wastes. So H196727 portable photometer is utilized for the measurement of color of the water samples. A variety of methods could be done by measuring DO of water samples. Among these three, the diaphragm electrode method is the most commonly used in determining the DO of water samples. So in terms of BOD or the biochemical oxygen demand in water, this directly affects the amount of dissolved oxygen in rivers, and this usually comes from leaves, animal manure, and many more. So BOD requires two measurements in order for us to test it. This allows the measuring immediately for dissolved oxygen initial, the incubation in the laboratory for 5 days, and the testing for the amount of dissolved oxygen remaining or the final. pH could be measured by using the filter papers. It could also be measured by using the litmus paper, a little different from pH paper, and will only determine whether the solution is acidic or basic. The most common and accurate method in measuring the suspended solid is by weight. So the water sample is filtered, dried, and weighed. So the usual apparatus for obtaining data with regards to the temperature is by utilizing the commonly known term thermometer. But the only consideration we would do is to record the temperature of each water samples as degree Celsius. So water samples to be tested with regards to the fecal coliform is measured by using the membrane filtration of a particular pore size. So this is generally 0.45 micron in size. And now, moving forward with the materials and methods done in the related studies the researcher obtained, entitled Preliminary Investigation of Water Treatment Using Moringa oleifera Seed Powder as a Natural Coagulant, a case study of Belat River in Malaysia. Water sample was collected at Belat River, located in the housing area in Gambang, Kuantan, and Pabang in Malaysia. The experiment was conducted at the Environmental Engineering Laboratory at University Malaysia, Pabang. So for the preparation of Moringa oleifera seed, it was purchased in Mitomasa SND, Kuala Lumpur. It was dried at room temperature for 1 day, and the seeds are crushed and grounded to obtain a fine powder. This powder has strongly attract moisture, so it needs to be dried at 50 degrees Celsius for 30 minutes in order to reduce the moisture content. For the testing of water quality parameters, jar test procedure was performed by jar test machine. The Moringa oleifera being used varies from different doses, so multiple testing was performed to differ the result based from the doses considered. The testing of water quality parameters, namely turbidity, which is measured before the treatment of Moringa oleifera seed powder by digital turbidity meter TB500G. So in measuring the chemical oxygen demand, spectrophotometer was used. This was preheated at 150 degrees Celsius. The jar test procedure was also applied in this part. The samples were put into COD reactor HACH DRB 200 and heated for 2 hours at 150 degrees Celsius also. This was accompanied by potassium dichromate solution. So the dissolved oxygen meter was used to measure the biochemical oxygen demand. Distilled water was then added to 1 liter volumetric flask and about 10 mm of water samples were transferred in BOD bottle after the jar test. So by means of dissolved oxygen in this study, the samples are measured by utilizing the DO meter. To prevent the evaporation of the solution, the bottles used are covered. The measured value of the dissolved oxygen would be obtained after 5 days. So the second study, the researcher included entitled Physico-Chemical and Bacterial Characteristics of Groundwater and Surface Water Quality in the Lagbe Town, treatment essays with Moringa oleifera seed. So Lagbe Town is the study area located in Infangni district. The study was skimmed through selecting 2 different sites around Lagbe, namely Zihan and Lagbe Center. So through utilizing a borosilicate glassware with 500 ml capacity, the water samples from different locations were collected. And as for the bacteriological analysis, the bottles were sterilized in autoclave at 120 degrees Celsius for 1 hour. Water samples from groundwater and surface water situated at different locations were collected during 6 months from September 2011 to February 2012. And as you can see here in our table, the groundwater samples were named as follows, accompanied with its respective coordinates as well as with the surface water. So in terms of preparation of coagulants, in this study, Moringa oleifera seeds were gathered from Zihan. The accumulated supernatant was filtered by utilizing the Wattmann pleated filter paper, and the collected filtrate there is used as coagulant. In this study, Moringa oleifera seeds were accompanied by the commonly used coagulant also, which is the aluminum sulfate. In terms of observing and measuring the parameters of this study, jar test assay was performed. The string of mixture was done through a rectangular pail of numeric flocculator Fisher-Broslock Scientific. So in this, the residual turbidity, pH, oxidizability with potassium permanganate and microbiological parameters were measured with WTW multimeter and HANA turbidimeter. The microorganisms distinguished in this study are Escherichia coli or E. coli, Klebsiella, Vibrio cholera, Enterococcus, Serratia, Aeromanus, and Aspergillus. So these are the microorganisms which are included or comprised in fecal coliform. These were processed and analyzed using the method SPSS 10.1.
For the results and discussion, the researchers provided a comparison of parameters of water in Calumpang, Belat, and Lagbe Town. In the presentation, we can see that there is a similarity between the parameters, though not totally similar, but it can be considered. In Lagbe Town, the researchers chose the W sub 7 parameter result of well water, and the parameter result of surface water is S sub 7 that can compare to the parameter of Calumpang River. And also in the Belat River, there are no bacteria spotted, but still, there is an appearance of other parameters. Also in Lagbe Town, the pH value of water samples of groundwater is a 5.8, and in the surface water is a 5.9, which indicates that it was near in the discrepancy of Calumpang River qualities, while the values of fluoride observed in the groundwater is 21.3 and in the surface water is 27.5, wherein the values of phosphate in groundwater are 0.70 and in the surface water is 0.26, which is considered far from the result of water quality in Calumpang River. Moreover, the nitrate of groundwater has a 52.8 value, which is far from the Calumpang River, and in surface water that has a 1.40 value that can consider near in Calumpang River quality, while the concentration of dissolved oxygen in groundwater is a 3.3 and in the surface water is a 3.30, which the values are near the discrepancy of Calumpang River quality. And when it comes to the fecal coliform, only the value of E. coli in groundwater has considered near and discrepancy of water quality of Calumpang River, which is 64,000. Furthermore, in Belat River, 2 parameters appear, the BOD and pH. The concentration of BOD in Belat River is 16, which is really far from the result of the water quality of Calumpang River, while in the pH value it has 6.67 to 7.60, which is considered that it is totally similar to the discrepancy of water quality of Calumpang River. However, some parameters are present in Balat River but not in Calumpang River. The COD, or the chemical oxygen demand as a result observed in water samples, was 127.33 milligrams per liter to the turbidity before treatment and reduced to 40.33 milligrams per liter when 0.01 of Moringa oleifera seeds powder with 2 millimeter particle size was utilized. Next is the ammonia nitrogen, which the result obtained fluctuated. The discarding of ammonia using Moringa oleifera seeds powder did not come up with a good result, as Moringa oleifera is a source of cationic coagulants. And last is the nitrate nitrogen, which the optimum dosage used to eliminate or remove nitrate in high turbidity water was 0.05 grams of Moringa oleifera seeds powder with 2 millimeter particle size. For lipid sound, the first one is alkalinity. For groundwater samples, about 2.10 degrees of Fahrenheit to 6.50 degrees Fahrenheit of total hardness was measured, and for surface water, it ranges from 1.90 degrees of Fahrenheit to 3.40 degrees Fahrenheit. This indicates that water is very soft. Next is the sulfate. For groundwater, 0.10 milligrams per liter and 0.50 milligrams per liter for surface water. Then the conductivity has average specific conductivity exceeds this limit for wells. W sub 4 had 687 microsiemens per centimeter. W sub 5 contains 556 microsiemens per centimeter, and W sub 6 had 530 microsiemens per centimeter. Next is the turbidity. The turbidities of groundwater samples are observed and analyzed as weak, which varies between 1.4 nephelometric turbidity units and 2.3 nephelometric turbidity units. And the turbidities of surface water samples from S sub 1 and S sub 2 are also weak and equal to 0.5 nephelometric turbidity units. The last one is organic matter. The dissolved organic matter of surface water was above 3 milligrams per liter, which represented the permissible limit except for the sample W sub 1. Lastly, bacteriological characteristics for the results and discussion. In the groundwater sample, there are aeromonas that vary between 192,000 UFC per ml and 256,000 UFC per ml respectively, and aspergillus that varies by 32,000. While in surface water, the number of Vibrio cholera varies between 16,000 to 32,000. Also, UFC ml was used for the process of the Lagbit sound, while MPN per 100 ml for the Calumpang river water. The difference between the two is that UFC is calculated from the bacterial and fungal colonies growing in a solid agar plate, while MPN is calculated from the viable bacteria growing in a liquid medium. With this kind of results, the researchers concluded that the state of Calumpang river water may improve using the traditional treatment that is widely known to be low in cost and highly available is the Moringa seeds. This comprises characteristics that aid its capability to purify and, as reported by previous studies, to be antibacterial as well. Based on the related studies, Moringa oleifera seeds revealed a substantial reduction of all pathogenic microorganisms existing in water samples of the water bodies being stated. By utilizing doses of Moringa oleifera seeds in water treatment, it also conceived different results that showed the effectiveness of Moringa oleifera as a coagulant for purification. The researchers' main goal was to emphasize the use of natural, eco-friendly, and cheaper materials that could actually be alternative but with the same efficiency as the costly materials imported or obtained internationally.
For the recommendation, the researchers advise the future researchers, local government unit, Municipality of Batangas, Community and Environmental and Natural Resources Office, and Department of Environmental and Natural Resources to perform further laboratory tests involving Moringa seeds and its capability to purify and remove bacteria present in the water sample obtained from the Calumpang River. The need to further conduct a study about Moringa seeds and ways to innovate the material to improve and develop more effective results is recommended. As well, through the recommended performance of laboratory tests, it could determine the duration of effect of Moringa seeds depending on its components. If it could be used for a longer period of time or for certain period of time only.
That's all